Hello everyone. Today my subject is biochemistry. Biochemistry. Okay. And my specific topic is enzyme inhibition. Okay. There is many kind of enzyme inhibition, like a reversible enzyme inhibition, irreversible enzyme inhibition. Tell me, what is enzyme? Enzyme is speed up the chemical reaction. It helps the when the biological reaction occurs, then enzyme helps to speed up the reaction. So and inhibition means what? You don't know what is inhibition. Inhibition means prevent. If you want to do something, it's prevent you to do something. This is called inhibition. Like, you cannot do, it's block, it's prevent you to do something. So for example, if enzyme want to do something, then inhibit, then particular things can prevent or block the inhibitor. So this is called, that's why this is enzyme inhibition. Enzyme cannot produce anything, and this is the things is called inhibition. And today I'll just only talk about the reversible inhibition. Reversible enzyme inhibition. There is three kind of reversible enzyme inhibition. One is called competitive, and another one is called what? Non-competitive, competitive, and uncompetitive. Competitive inhibition. Okay. So there is three kind of reversible inhibition: competitive inhibition, non-competitive inhibition, inhibitor, and uncompetitive inhibitor. So okay. So let's start the competitive inhibition. Competitive inhibition. Competitive inhibition. I'll explain you what is the simple things for competitive inhibition. Competitive inhibition is really simple. How this is simple? Because look at the I'll draw for you. Okay, so it's going to be easier for you. But I'm not good in drawing. I'll try my best. For example, I'm not good in drawing, okay? So for example, think this one is enzyme, okay? Think this one is enzyme. This one is enzyme, and think this is your substrate. Think this is your substrate. And think this is your inhibitor. Think this is your inhibitor. So the understanding part is, look right now. So when enzyme and substrate, they bind with each other. So how they bind? Look right now. So this one is coming. Okay, so why this one is can bind? Because for example, if think this is like that. For example, think your substrate is like that. You cannot bind with this one because the enzyme has a different kind of shape or active site, and this active site you need a specific bind, because it's specific what is called shape. So this substrate has a specific shape, so that's why this substrate can bind with the enzyme. So think what the competitive inhibitor, what it does. Competitive inhibitor, what it does, this part, right, is the same as like this one. You see the same, this part, this shape is like the same as like this one. This shape is same as like this one. So what can do? What can do? The competitive inhibition compete with the substrate. So this one compete means it's fighting, it's fight with the substrate, with this one. And compete means, like for example in my class I'm competing with somebody, like my friend get a 99 and I'm competing to get 100. So that's the same as like this one. My inhibitor is competing with the substrate, and before substrate bind to the enzyme, my inhibitor binds to the this side. My inhibitor, this one, is bind to there. Bind to this one. Because why can bind? Because this one is shape, the enzyme shape, enzyme active side, and my inhibitor active side is the same kind of shape. So that's why this inhibitor can bind with this one. Okay. So when you're going to be writing in your exam, how you're going to be write nicely, like competitive inhibitor compete with the substrate, and bind with the active side of enzyme. Then this active side, my substrate cannot bind. So what happened when substrate cannot bind? When this one is bind with what? My enzyme. But you can overcome this inhibition. The competitive inhibition cases, you can overcome this inhibition. How? If you increase the substrate. For example, there is a one substrate, right? And if you increase another more substrate, then you can inhibit. How? Because I'll show you how it's going to be. Okay. So how you can inhibit? Think this one. E plus S gives us ES complex. Then ES complex gives us E plus P, means product. When inhibition bind, then what happened? It gives us EI complex. The understanding part in here, look right now. When E plus S they bind, form a ES complex. Then this is called loosely attachment or loosely connection. Then this one can dissociate. And when this one can dissociate, then again it go back to the original enzyme, like how it was. Then it go back to the original enzyme. Then if you add another substrate, for example, if you add another substrate, then this inhibition, this competitive inhibition, you can overcome. How? Because when this one is dissociate, it goes to the original enzyme. Then this original when it's come back to the original enzyme, then it is active to bind with something. So if you add the substrate, then what happened? Then you can overcome to this competitive inhibition. So you understand what I'm trying to say. When this one is from, then this is when this is again dissociate, this is go back to the original E. Then if you add to another substrate, then you can compete the inhibition. But the classical part, the main part, what is the main idea of this one? What is the main things? What is the main purpose of these things? The main purpose of these things, that when the competitive inhibitor bind with this one, BMX does not change. BMX does not change. This is the classical part. BMX does not change. BMX does not change, but Km change. So Km change. BMX does not change, but the Km change. So this is the classical part that you have to understand from the competitive inhibition. Okay. So if I show you the graph, then you will clearly understand that what I'm trying to say. So I'll draw for you the graph. First, I will show you the graph in the Michel's-Menten equation. I will show you the graph how it's going to be look like in the Michel's-Menten equation, and then I will show you the linear bark plot or double reciprocal plot. I'll show you that how it's going to be, how your graph is going to be look like. So first, understand the Michel's-Menten. Menten means graph for competitive inhibition. So look right now how it's going to be look like. Reaction velocity B naught, and there is a substrate concentration. Substrate concentration S. Okay. Yes. Okay, look what happened. Then here, for example, your curve is going to be hyperbola. Okay, I'm not good in drawing, okay, but I'm trying to explain you, okay. This is going to be something like this. Okay. Think this one is no inhibitor. No inhibitor means it is bind with substrate. It's a regular one. This is no inhibitor. No inhibitor. No inhibitor, you can also give this one is I minus. I minus means no inhibitor. No inhibitor. So look right now what happened. This is your Bmax. Right? This is your Bmax. B maximum. Bmax means the B maximum. This is your B maximum. So you do know B maximum, Bmax on substrate concentration, on Km on substrate concentration is equal half of Bmx. So Km substrate concentration, Km on substrate concentration is equal half of Bmx. Half of Bmx means what? In here is going to be your half of B. If you compare to this one and this one, what is your half? Half is going to be in here, around in here. Here is going to be your half. Here will be your, what? Half. So half Bmx means half Bmx in here. This is your half Bmx. Okay, this is your half Bmx. And this is your Km. So this one is what? This one is no inhibitor. Okay. This one is with inhibitor. This one is what? With inhibitor. With inhibitor you can write I plus. You can write what? I plus, and this is with inhibitor. And always remember, the first one velocity is higher velocity. This is a like not that much speed, that much velocity. So this one is going to be lower than, this one is obviously is going to be lower than the first curve line. This second line curve is going to be lower. So look right now what happened. This one, when this one with inhibitor is lower the curve, but the thing is it's going in some place. This is reach the maximal velocity. Bmax, it's some place in here. Before this one is reach the maximum velocity in there, then second one with inhibitor, this one is reach the maximal velocity in here. So what happened? Bmx does not change. So Bmx, you can write Bmx does not change. How does not change? Because some place with inhibitor, this one is touch this one, the maximal velocity, and this one also in the some place, some area, this one is touch the Bmax, and this one is also in some place, this one is touch somehow this one is touch the Bmax. So you can write Bmax does not change. Bmax what? Bmax does not change. Bmax does not change. But what happened to your Km? This is the very this is now understanding part. Your Km is now changed. Give this one name is Km prime. Your Km is not, now what happened to your Km? Your Km is now changed. How? Look, your Km was in here. Right now is increase. It goes to the Km in here. So Km change means Km increase. Km change means Km increase. But Bmx does not change. This is the main story of competitive inhibitor. But one thing you have to remember, that you can overcome the competitive inhibitor. Why? Because when this one is again, because this is reversible reaction, when it dissociate, then again my enzyme become how it was original, and then again if you add the substrate, you can overcome the competitive inhibitor. This is the things. Right now I'll show you how you can compare to this one and your what is called this one to double reciprocal plot, or it's called linear viewer plot or something, bar plot. Okay, I forget the guy name, is very hard. Okay, but I can I think I do know the what is called linear bar plot. Okay, linear bar plot basically is also simple. How? Okay, this is called a double reciprocal plot. Okay, so I'll draw for you. This is one B naught, and this is one substrate, 1 over substrate, and look what happened. This is your what? Okay, minus 1 by Km, and this one, this part, look right now, this part is called 1 over Bmx. This part is called 1 over Bmx. So we do know that Bmx does not change. Bmx does not change means what? This is no inhibitor, I minus, and Bmx does not change, and you do know the second one is going to be lower. Then if it is 1 over this one, that means it's going to be the higher, you know, right? Before this, look right now, before this one, no inhibitor, and inhibitor with this one is little bit lower. You see the curve is little bit lower than this one. So if it is lower than this one, it's going to be go to the up because it's 1 over, it's reciprocal. So that's why this one is going to be go to the up like that. You see, this is with inhibitor or I plus. With inhibitor I plus, no inhibitor I minus. So what happened? Look right now. It's give this one is 1 over Km prime, and this is 0, right? So your question is right now, how my, okay, you understand right now very clearly, because they touch in the same place in here. That's why Bmx does not change. You understand, but you are not understanding how this one is changing. It's very simple, because think this one is minus 4 and think this one is minus 3. Who is very closer to 0? Minus 3 is very closer to 0. So this one is very closer to 0 means Km is increasing. So you see the Km is increased. and this is double reciprocal plot or Lineweaver-Burke plot, and this is Michaelis-Menten equation plot. So I hope you guys understand competitive inhibitor. Then in my next video I'll explain you, because my video is going to be very longer, so I'll explain in my next video non-competitive inhibitor and uncompetitive inhibitor. I hope you guys like my videos is about competitive inhibition, and if you really like my video, don't forget to share with your friend and don't forget to subscribe. If you have any question, you can email me anytime. My email address is alamgirhussain1992@gmail.com, and hopefully see you in the next videos. Thank you for watching my video. Study hard.